Hello everyone, welcome to Victory Batch. This is me Arvind Suthar. I welcome you all in this pure English batch for class 11 JEE and NEET. Today we're going to do one short lecture on sequence and series, which is a very easy kill category topic as far as JEE mains and advanced is concerned. So here we go towards this session and we will be covering this topic entirely in one go, and that too in the very short span of time. So what I'll recommend you after doing this particular lecture is practice, because the more you're going to practice, the more you're going to retain and you're going to have good command over the topic, right? Here we go. Now there is a thing, general term or the nth term in each and every sequence. Okay, T1 means first term, T2 means second term, T3 means third term, and so on. So Tn is nothing but nth term, right? Yes. There is a very important thing, sum of terms. Let me explain you this particular thing, that if I am talking about sum of the terms till first term, if I am talking about sum of all the terms which are coming till first term in a sequence, that is going to be nothing but equal to T1 only. So T1 is nothing but sum of the first one term. Okay, what do you understand by this? I'll explain you in case you are not aware of this. T1 plus T2 is sum of the first two terms in a sequence. T1 plus T2 plus T3 is nothing but sum of the first three terms in a sequence, and so on. You have to apply the logic. So T1 plus T2 plus T3 plus T4 is going to be nothing but sum of the first four terms in a given sequence. I hope you understood this. Okay, so you can say that S1, so you can say one thing from here, that T1 plus T2 plus T3 plus and so on till Tn minus 1. Let me tell you these things. We can write down this thing as S1 as well. We can write down this thing as T2, sum of the first two terms. We can write down this third thing as S3, that is sum of the first three terms, and we can write down this particular thing as sum of the first four terms, that is S4. So this particular thing going from T1, T2, T3 till Tn minus 1 can also be called as Sn minus 1. This n minus 1 is a clubbed thing, okay? Yes. And also if you see T1 plus T2 plus T3 and so on till Tn this time, so it is going to be sum of the first n terms, so it will be denoted as Sn. Now if I am calling this as 1 and calling this as 2, in general if I do 2 minus 1, we can say that on the left hand side only Tn will remain, and on the right hand side Sn minus 1 will come. So this is a very important formula, that nth term in a sequence can be written as Sn minus 1. Okay, now this formula is very important as far as JEE is concerned, because a lot of questions has been asked earlier on this, that nth term in a sequence is nothing but the difference between sum of first n terms and sum of first n minus 1 terms. So that is nothing but equal to Sn minus Sn minus 1, that is equal to Tn. Okay, let me tell you an example based on this. Let's say if Sn is given to you as n square plus n, and the question is asking you to write down Sn, and the question is asking you to write down Tn. Okay, let's say in a question Sn is given to you, sum of first n terms, and the question is asking you to write down nth term, that is Tn. Now without even having Sn minus 1, you can find out the value of Tn by using this particular formula. Sir, how come Sn is given to us but Sn minus 1 is not given to us? And then in that case, how can I find Tn? Because if there are three variables, then in order to get the third one, we should have at least two. Let me tell you one very important thing over here, that you have Sn minus 1 already with you when you have been given Sn. How, sir? Let me tell you. Since Sn is equal to n square plus n, Sn minus 1 will be what? Simply put n is equal to n minus 1 over here. So if you put n is equal to n minus 1 over here, we do get nothing but the value of Sn minus 1. Why? Because if I need to find out S1, then S1 will be what? I simply need to put n is equal to 1, that is 1 square plus 1. If I want to find out, let's say S2, then S2 is nothing but simply put n is equal to 2 over here, so 2 square plus 2. If I want to find out, let's say S3 over here, then we simply put n is equal to 3 over here. So that's what I am saying, that if Sn is given to you, then you can comfortably find out Sn minus 1 from there by simply putting n as n minus 1. So the moment you have this thing, you can find out Tn quite comfortably, yes or no everyone. So we can do Sn minus 1, we are simply doing 1 minus 2. What we gonna get is nothing but the value of Tn, and that is going to be equal to what? That is going to be equal to n square plus n minus n minus 1 ka whole square plus n minus 1. Simplify this expression, what we get is n square minus n minus 1 ka whole square minus n plus n minus n minus 1 over here. So we can write a square minus b square over here. So it will become a plus b into a minus b. So 2n minus 1 into 1 will come over here. A plus b into a minus b, yes. So this will come over here, and then over here if you see plus 1 will come. So ultimately it is going to be 2n minus 1 plus 1, that is equal to 2n only. I hope you guys are clear with this. Anyone is having any issue in this, feel free to reach out to me. So the value of Tn is what you are having as equal to 2n. Quite an easy thing. Now Tn is nth term. So here if you put n is equal to 1, we're going to get the first term. So first term is going to be 2. If we put n is equal to 2 over here, we're going to get T2. So T2, that is second term, is going to be 4. If we put n equal to 3 over here, we're going to get T3, that is third term, that will be equal to 6. That is the thing. So nth term can always be written as Sn minus 1. If Sn is given to you, then from there you can find out Sn minus 1 quite comfortably by simply putting n as n minus 1, and the moment you subtract these two things, what you get is nothing but the value of Tn, and Tn is nothing but the nth term in that particular sequence. Sn is nothing but sum of the first n terms. Sn minus 1 is nothing but sum of the first n minus 1 terms. I hope you guys are clear with this. Now we're going to talk about two things. Let's combine AP and GP together, because I think now you can understand it quite easily. If a kid has already gone through this chapter, then he or she will be able to understand all the things that I'm going to explain over here. AP and GP in a single slide. Let's talk about this. Let's say we are taking a term A and we are continuously adding a same number D again and again and again. If we add D to this, we're going to get A plus D. If we add D to this, we're going to get A plus 2D. If we add D to this, we're going to get A plus 3D, and so on. Here in a geometric progression, let's say we are starting with the first number A can be any real number, okay, and if we multiplying this with R, we're going to get AR. If you multiply this with the same term R again, we're going to get AR to the power 2. If you multiply this with R again, we're going to get AR to the power 3, and so on. So here we are adding the same number again and again in an arithmetic progression, whereas in a geometric progression we multiply by same term again and again and again. So here this is the first term, this is the second term, this is the third term, this is the fourth term, and so on. And here this is the first term, this is the second term, this is the third one, this is the fourth one, and so on. So over here, if I tell you to write down a general formula, then the nth term Tn can be represented as what? A plus n minus 1 into D. Whereas if I talk about nth term, that is Tn over here, you can write it as A into R to the power n minus 1. Yes or no? Look, if you put n is equal to 1, then you're gonna get A. If you put n is equal to 2, you're gonna get A into R. If you put n is equal to 3, then you're gonna get AR to the power 2. If you put n is equal to 4, you're gonna get A into R to the power 3, and so on. Look, these are the terms getting formed. Over here also, if you put n is equal to 1, you're gonna get A. If you put n is equal to 2, you're gonna get A plus D. If you put n is equal to 3, you're gonna get A plus 3D, A plus 2D. If you put n is equal to 4 over here, you're gonna get A plus 3D, and so on. Okay, so an arithmetic progression is all about A and D. This is all about A and D. That means what? Is all about A and D. That means if you know the values of A and D, you can write down the arithmetic progression quite comfortably. Whereas a geometric progression is all about A and R. That means if you know the values of a and r, then you can write down the value, then you can write down all the terms in a geometric progression quite comfortably. I hope you understood this particular thing. Okay, so we can say one thing in an arithmetic progression, that if we take two consecutive terms, the later term minus the earlier term is going to be nothing but the common difference. Yes or no? That is tr minus 1 for any value of r is nothing but equal to common difference in an arithmetic progression. Yes or no, everyone? Yes. All right, so that's why we call it as d, common difference. Okay, is number one thing is whether to identify a particular thing is an AP or not. So 1 3 5 7, let's say a sequence is given to you, is it an arithmetic progression? So you can see that if you do t2 minus t1, if you do t2 minus t1, 2 is coming. If you do t3 minus t2, 2 is coming. If you do t4 minus t3, 2 is coming. So that's why this is an arithmetic progression. Okay, over here the first term is 1 and the common difference, that is t2 minus t1, the value is coming out to be 2, that therefore the common difference is equal to 2. So what is the nth term? The nth term tn can be written as a plus n minus 1 into d, that is equal to 1 plus n minus 1 into 2. So ultimately it is coming out to be 2n minus 1. So n here belongs to a natural number, because either the term will be 1, either the term will be 2, either the term will be 3, either the term will be 4, either the term will be 5, either the term will be 6. It cannot be that tell me the 6.5th term of the AP. This will never be. That this is never going to happen, right? Either the term will be the first one or the second one or the third one or the fourth one. That means n has to be a natural number. So over here the nth term will be coming out to be 2n minus 1. I hope you guys are clear with this particular thing. Okay, over here it is given to me the third term of an AP is minus 11 and the ninth term. Okay, how can we write down the third term of an AP? A plus 2d, yes or no? Okay, it is minus 11 given to me. Ninth term of the AP can be written as a plus how many d's? 8d. Yes. Okay, these are two equations, two variables. Can we solve these two equations for the value of a and d? Yes. If we do 2 minus 1, we can have 6d is equal to minus 35 plus 11, that is equals to minus 24. So the value of d is coming out to be minus 4. The moment we got the value of d as minus 4, putting this in 1 or 2, putting it in 1 or 2, we can get the value of a quite comfortably. So a is going to be minus 11 minus 2d, that is minus 11 plus 8. So a is equal to minus 3 will come. Yes or no? So the moment you have got the values of a and d, can you find out the nth term of the AP? Nth term of the AP will be written as a plus n minus 1 into d. Since you have the value of a, you have the value of d, just put it over here and you will get the value of the nth term, and the nth term is coming out to be minus 3, this, that is tn equal to 1 minus 4n. If you put n is equal to 1 over here, you're going to get the first term, that is minus 3. If you put n is equal to 2, you're going to get minus 7, that is the second term. If you put n is equal to 3, you're going to get the third term, that is minus 11. If you put n is equal to 4, you're going to get the fourth term, that is minus 15, and so on. All the numbers can be comfortably found out from here. I hope you guys are clear with this. Okay, let me tell you a very important concept, that sum of n terms of an AP, which is written as Sn, is nothing but equal to n by 2 times of 2a plus n minus 1 into d. Yes or no? I hope you guys are aware of this. That is equal to t1 plus t2 plus t3 and so on till tn, where t1, t2, t3, where t1, t2, t3, t4 and so on are forming an AP. If t1, t2, t3 and so on are forming an AP, then the sum of the n terms of the AP can be written as n by 2 times 2a plus n minus 1 into d. Okay, another formula is there, or the formula is Sn equal to n by 2 times first term plus last term, first term plus last term as well. I hope you guys are aware of this formula. Okay, so this is a very important thing. Okay, now over here it is given to me, understand one thing, that Sn is nothing but a quadratic in n. Can you observe that this is a quadratic in n? Because when this n will be multiplied with this 2a, you're going to get a linear term only. But when this n will be multiplied with this n wala term, over here a quadratic in n is going to form. So whenever Sn is given to you as a quadratic in n, by default you have to assume that it is going to be summation of an AP only. So over here in the problem, look, if for a sequence Sn is given to me equal to this, the moment we observe over here that Sn is nothing but a quadratic in n, can we identify that this Sn is going to be nothing but sum of terms in an AP only, because it is coming as a quadratic in n. This is a very important concept. Over here in the question it is telling me to prove it. So there are multiple ways to prove it. Let me tell you, S1 is going to be what? S1 is going to be by putting n is equal to 1. The moment we put n is equal to 1 over here, we get S1 equal to 2 plus 5, that is equal to 7, and I hope you guys know that S1 is nothing but equal to T1 only. Okay, the moment we put n is equal to 2, we get the value of S2. S2's value is going to be 2 into 2 square plus 5 into 2, so that is going to be 2 into 2 4, 4 into 2 is 8, 8 plus 10 is equal to 18, so this is going to be nothing but T1 plus T2. I said okay. Moving ahead, if we put n is equal to 3, we can see the value of S3, so that is going to be 2 into 3 square plus 5 into 3, so that is equal to how much? 18 plus 15, 18 plus 15 is nothing but 33, so its value is equal to T1 plus T2 plus T3 and so on. You can evaluate S4 and so on, all the terms. Okay, so from here you have the value of T1 equal to 7. If the value of T1 equal to 7, then the value of T2 will be equal to 11. If the value of 7, if the value of T1 is 7, T2 is 11, then the value of T3 is going to be what? T3 is going to be 15 and so on. So can you observe that T1 equal to 7, T2 equal to 11, T3 is equal to 15 is there. So you can form a sequence and you guys can see that this is nothing but an arithmetic progression only. Right? So again I am telling you a very important concept, that whenever, let me write down this particular thing as a note, that whenever Sn is given as quadratic in n, then it has to be summation of n terms in n, or summation of n terms in an AP only. Okay, this is number one. Number two, also if you can recall that Tn, that is the nth terms formula for an AP, is nothing but a plus n minus 1 into t. So there Tn is coming out to be as a linear in n. So we can say this also as a point, that whenever Tn, that is nth term, is given as a linear expression in n, then it has to be forming an AP only. It has to be forming an AP only. Okay, so these are two very important concepts that you always need to keep in your mind. Okay, find the sum of first 5 terms of an AP if the third term is given to you equal to 4. I said alright, the first term, the sum of the first 5 terms is what we want to find out. That means we want to find out T1 plus T2 plus T3 plus T4 plus T5. Okay, the value of this is what is the question asking me, and the value of third term, that is a plus 2d, is given to me equal to 4. I said okay, T1 is nothing but a, T2 is nothing but a plus d, T3 is nothing but a plus 2d, T4 is nothing but a plus 3d, T5 is nothing but a plus 4d. So this is going to be equal to what? 5 plus how many d's? 3d, 6d, 10d. 5 plus 10d, we can write down this particular thing as 5 times of 5a plus 10d. So we can write down this particular thing as this, and the value of a plus 2d is already given to me, so we can put it over here and we can get the answer quite comfortably. So the answer is coming out to be 20. That is, the sum of the first 5 terms of an AP, if the third term is given to me equal to 4, is going to be nothing but equal to 20 only. I hope you guys are clear with this. Alright, let's do this particular problem, kids. Come on. A2 plus A5 minus A3, if the terms given to you are in an AP, then one thing, and another thing is A2 plus A9 equal to 17 given to you. We need to find out the 20th term of the AP. So if we write down the equation from here, it is going to be A plus D plus A plus 4D minus A plus 2D, and its value is equal to 10 given to me. So here we can say that A plus 3D's value is equal to 10 given to me, calling it as equation number 1. Alright, moving ahead from here, if you see, A2 is nothing but A plus D and A9 is nothing but A plus 8D. Okay, so over here this becomes 2A plus 9D equal to 17, calling it as equation number 2. So if we solve these two equations. Two unknowns are there, a and d. Can we guys find out the values? Okay, if we multiply it by 2, then we're gonna get 2a plus 6d is equal to 20. Now subtracting the two equations, 3d's value is going to be equal to minus 3, that means d has to be equal to minus 1, and if d's value is equal to minus 1 means a's value is going to be nothing but equal to 13. So if you have got the values of a and d comfortably, the question is asking you to get the value of a20, that is a plus 19d. I hope you can get it quite comfortably. Minus 19 plus 13, that is equal to minus 6, so B for Bombay is going to be your correct answer. Anyone is having any difficulty in this, feel free to reach out to me. Always remember that if there are n variables, then there has to be n equations in order to solve for those particular variables, and the moment you got those variables, then in an AP I don't think anything else is required. Alright, so this was the problem asked in JEE Main 2019, 10th April shift 1. Let's do this question. If a1, a2, a3 are few terms given to me in an AP and the value of this expression is given to me 114, we have to solve the problem. Now there are other methods as well. I'll tell those methods once I move more into AP, but there's a property of AP that first term plus last term of the AP is equal to second term plus second last term of the AP equal to third term plus third last term of the AP plus equal to fourth term plus fourth last term of the AP, and so on. So from that also you guys can do this example. I hope this clicked your mind if you have already studied this particular chapter. Okay, let's first write down this particular expression, a1 plus a4 plus a7 plus and so on, means a1, a4, a7. So next term is going to be a10, then a13 till a16. The summation is given to me equal to 114. So we can say that a1 is the first term of the AP, I can write it as a. A4 is fourth term of the AP, I can write it as a plus 4d. A7 is the seventh term, I can write it as a plus 6d. A10 can be written as a plus 9d. This a plus 12d. This a plus 15d is equal to 114. Now if that is the thing, then how many terms are these written? These are 6 terms, so it is going to be 6a, okay, 9d, 18d, 18, 30d, 45d. So this is equal to, this particular expression is given to me equal to this. I said alright, moving ahead, calling it as, let's say, equation number 1. Okay, talking about this particular expression is going to be a plus 5d, because 6th term of the AP will be written like this, 11th term will be written as a plus 10d, and the 16th term will be written as a plus 15d. So ultimately it is coming out to be 4a plus 25, 30d. Okay, I can take 2 common from here. The moment you take 2 common from here, you can write it as 2a plus 15d, and over here if you see, if we take 3 common from here, then it is going to be 2a plus 15d equal to 114. So from here you can get the value of 2a plus 15d as 114 by 3. You can simply put it over there and can get the answer of the question without any difficulty. Yes or no? 2 times of 114 by 3 has to be your answer of this particular question. So 3 ones are 3, 3 threes are 9, 2 4. This 76 has to be the correct answer. That means option B. Since we were having only one equation in A and D from here, so how can we solve this question? Is the only possibility is without even finding out the values of A and D, because if A and D are the 2 variables, and if I want to solve for A and D, then there has to be 2 equations at least. But unfortunately I was having only one equation, so ultimately this thing has to come in my mind that I have to use some value from here and I have to put it in the expression so that I can get the answer of the relevant question, right? Okay, moving ahead. If a1, a2, a3 and so on are few of the terms given to you in an AP 2019 question, it is also 12th April shift 2 question. This value is given to me. I said fine, a1 can be written as a, a7 can be written as a plus 6d, a16 can be written as a plus 15d equal to 40. So over here if you see 3a plus 21d equal to 40, that means we can say that a plus 7d's value is going to be nothing but equal to 40 by 3. Okay, some of the first 15 terms of the AP is what we want to find out. So we can write it as 15 by 2 first term plus last term. Yes or no everyone? The last term, that is the 15th term, will be written as a plus 14d only. So it is equal to 15 by 2 times 2a plus 14d. So over here you can see that if we take 2 common from the bracket over here, this can be written as something like this. So 2 and 2 cancelled away. So this is going to be 15 times of a plus 7d only, and a plus 7d's value is already written over there. So it is going to be 15 times of 40 by 3. So what is the answer, kids? 200? Yes, A is the correct answer. I think the question should be clear to all of you guys. Anyone is having any issue in this? Do let me know. General expression for sum of terms that we have just seen. The sum of n terms of an AP can be written in two ways. One is like this, number of terms by 2 times first term plus last term, and the another formula is this, Sn, sum of the first n terms of an AP is equal to n by 2 times 2a plus n minus 1 into d. Yes, facts related to an AP. If a fixed number is added or subtracted each term of a given AP, then the resulting sequence is also an AP with the same common difference. Yes or no? Yep. Let's say for an example 1, 3, 5, 7, 9 and so on. If this is an AP, if from each and every term, if I am subtracting minus 2, okay, from each and every term I am subtracting or adding the same thing, then over here the terms are going to be minus 1, then over here 1, over here 3, then over here 5. Don't you think that the resulting sequence is again going to be in an AP? Yes, and that too with the same common difference is what the question telling you. So if an AP is given to me and from each and every term I am subtracting or adding a same number to that, then that resulting sequence is again going to form an AP, but with the same common difference, only the common difference is not going to change. Okay, now this property will be used very frequently. This property will be used very frequently. Let me tell you about this. In problems like this, okay, in problems like this, let's say A, B, C are given to me in an AP, and if I want to know about, if I want to know about 0, B minus A and C minus A, these three things will be where? These three things will be in what? AP, GP or what? So questions like this will come. So understand, if these terms are given to you in an AP, that means if you subtract same number from all these three numbers, the resulting sequence is again going to be in an AP only. So if you subtract A from here, you will get 0. If you subtract A from here, B minus A. If you subtract A from here, you are going to get C minus A. So you are subtracting same numbers from these numbers. That's why this resulting sequence is also going to be in an AP only. I hope you people understood. This is a very important part of the problem. I have seen over the years that kids are not able to apply these particular concepts in the problem solving. So that is very important. Keep this point in your mind. Okay. If few of the terms are given to you in an AP, let's say T1, T2, T3, T4 and so on, and these are given to you in an AP. If you are multiplying each and every term by a same constant, let's say K, so this number will become KT1, this will become KT2, this will become KT3 and so on. So the resulting sequence is going to be in what? The resulting sequence is also going to be in an AP if the common difference of this is a D. If the common difference of the earlier one is equal to D, then what will be the common difference of the new sequence? The common difference of the new AP is going to be K times D. In the previous one, it was same, but over here it will become K times of the D. Okay. Okay. Whereas if I am dividing all the terms by a same number K, then in that case also the resulting sequence is going to form an AP only, but this time with what common difference? But this time with a common difference equal to D by K. This is also very important. Keep this thing in your mind. Okay. Yes, if let's say two APs are given to me, A1, A2, A3 and so on, B1, B2, B3 and so on, and if I am adding the corresponding terms, that means A1 with B1, A2 with B2, A3 with B3 and so on, I am getting a new sequence like this. Is this again going to be an AP? Yes. If the common difference of this AP is D and the common difference of this AP is D dash, then the common difference of this new AP is going to be D plus D dash. Keep this thing in always in your mind. Alright. Okay, let's do this JEE Main 2019 question. If the 19th term of a non-zero AP is 0, okay, 19th term means A plus 18D, the value of the A plus 18D is equal to 0 given to me, then the 49th term upon 29th term is going to be what? 49th term upon 29th term is going to be what? 49th term upon 29th term is going to be what? So this is A plus 48D divided by this is A plus 28D. So A's value can be written as minus 18D. So minus 18D plus 48D divided by minus 18D plus 28D is what we're going to have. So over here it is going to be 30D divided by 10D. So D cancelled away. So it is going to be 3 only. Yes, the answer, the correct problem is going to be 3/1. Now this was a problem asked in JEE Main 2019. Right. Okay, moving ahead. Number of the common terms in both the sequences 3, 7, 11 and so on. Okay, till 407. So if you write down the terms, look, is this an AP 3, 7, 11 and so on? Yes, okay. So let me write down a few terms of the AP. Will the AP be looking like this? Yes or no? Yes, the AP will be looking like this particular thing. Till 407 you have to move, alright. And the another thing, 2, 9, 16, 2, 9, 16, this is what? 2, 9, 16, 7, 7, 7 you are adding again and again, yes or no? Okay, is this also an AP? Yes, 30, 37, 44, 51, 58, okay, 2, 9, 16, 23, 30, 37, 44, 51, 58, then 65, then 72 and so on is what you're gonna have. Okay, if you see the common terms coming in these two, if you see the common terms means the terms which are coming in both of these. So this is the common term 23. Then moving ahead, which of the following term is going to be common? 20, 51. Have a look at this, 51 and so on. Then which of the term is going to be common? Over here, if you see over here, it is going to be 71, like that and so on. Terms will come. These are the common terms. Now the concept is, if you are taking common terms of two APs and forming an arithmetic sequence, that arithmetic sequence is again going to be an AP with the common difference as the LCM of common difference of these two APs. So this AP is having common difference equal to 4 and this AP is having common difference equal to 7. So the LCM of D1 and D2 is going to be what? The LCM of D1 and D2 is going to be 4 times 7, that is equal to 28. So you see one thing over here, that if you add 28 to this, this term is coming. If you add 28 to this, another term will come and that will be equal to 79 people. If you add 28 to this, another term will come to this and so on. So it is asking us the question that how many terms are common in these two APs. Now over here, in the first AP, the highest term is 407 only, whereas in the second AP, the highest term is 905 only. So the last common term will be either 407 or less than that only, because this AP is going till 407 only. So if we are writing down the common terms, then the common term has to be less than or equal to 407 only. It can never be beyond 407. Yes or no? Okay. So if we go like this, we can see that 23, 51, 79 and so on. We are moving. So the last term in this sequence will be 405 or less than that. So if you want to write down the nth term of this, we can write it like this: a plus n minus 1 into d should be less than or equal to 407. So if we solve this particular equation, n minus 1 times 28 is less than equal to 23, we need to subtract from here, so 4 and 38. Okay, so if we divide this particular thing by 28, then we're gonna get this thing. Okay, so n is nothing but less than or equal to something like this. If we evaluate the value of this particular expression, then 10 times is 280, then 28 into 13, if we do, how much it is going to be? 8 3 is 24, 4 2, 5 3 is 6, 7 8, then 8 and 2 4 16 1 364. Okay, yes, so this is going to be 13 point something. Okay, so n has to be less than or equal to 14 point something. N has to be less than equal to 14 point something means n is a natural number only. N can never be a fraction or decimal or like that. So n equal to 13 terms are there which are, okay, n equal to 14 terms are there which are common, right? Because 407 is not a common term, that's why it is coming as 14 point something. Okay, 407 is not a common term, that's why 14 point something is coming. So ultimately the number has to be lesser than 407, so in that case it is going to be the 14th term only. I hope you people understood this particular problem. So these two following APs will be having 14 terms as common, because the first AP is going till 407 only, so the last term has to be last common term in these two APs has to be less than or equal to 407 only. Alright, moving on to the next problem, kids. For an AP T10, 10th term can be written as a plus 9d and its value is 1 by 20. Okay, and the 20th term can be written as a plus 19d. Okay, if you do subtract 2 minus 1, then you can get the value of 10d equal to 1 by 10 minus 1 by 20. So it is going to be how much? 10d is equal to 1 by 20, so it is going to be d equal to 1 by 200. If d's value is 1 by 200, then can we get the value of a? Yes, we can put it over here, and a's value is going to be 1 by 20 minus 9 by 20. So that is going to be how much? 1 by 20 minus 9 by 200. So that is going to be 1 by 200 only. Yes? Yep, 1 by 200 only. So sum of the first 200 terms, that is S200, is what question asking from me. So we can write it down as 200 by 2 times first term plus 199 into d. Okay, so that will be equal to 200 by 2 into 100 is the answer. No? N by 2, 2a, sorry. 2 into a plus n minus 1 into d. So this is going to be 201 by 200. 200 and 200 goes away. So 100, 1 by 2 has to be our answer, or 201 by 2. Right, I hope you people got this particular thing, right? So the answer is there with you. Yep. So the answer is D for Delhi. This is in mixed fraction written 100, 1 by 2, okay, and its value is nothing but equal to 201 by 2. Alright, moving on to the next problem. These are the few terms given to me in an AP. I would like to tell you one very important property of the AP over here, that since these are 45 terms, these are 45 terms in an AP. 45 terms in an AP. So let me tell you, first term plus last term will be equal to second term plus second last term, will be equal to third term plus third last term, will be equal to fourth term plus fourth last term, will be equal to fifth term plus fifth last term, will be equal to sixth term plus sixth last term. This happens for each and every AP irrespective of the first term and the last term, kids. Okay, so this happens with the or irrespective of the common difference as well, and so on. First term plus last term equal to second term plus second last term equal to third term plus third last term equal to fourth term plus fourth last term equal to fifth term plus fifth last term, and so on. This is a very important property of an AP. Okay, over here if you see, then you can see that over here one thing will come, since these are total odd numbers, 45 terms are odd, so the middle one is going to be what? The middle one is going to be 23. So ultimately from initial, if you see the 23 term, it is going to be this, and from ending, if you see the 23rd term, it is again going to be this only. So we can say that A1 plus A45's value will be equal to twice of A23, A2 plus A44's value will be equal to twice of A23. So like this you can see that 22 such pairs will form, 22 times of A1 plus A45 plus A23 will come. And over here if you see 22 times of A1 plus A45 is nothing but equal to this particular thing. So you can have your answer quite comfortably now. So it is going to be what? It is going to be equal to 45 times of A23, and now you can write down the answer quite comfortably, because 45 times of 45 is how much? I hope you guys know. Yes, anyone is having any difficulty in this, do let me know, bacha party. There has to be no confusion at all, right? So 2500, it has to be lesser than that. So 45 times 45 is more than 16. So this is not the answer, this is not the answer, this has to be the answer, right? So the answer has to be B for Bombay. I hope you guys are clear with this particular problem. Alright, talking about this, where I was telling you that if A, B, C are given to you in an AP, and I am talking about 0, B minus A and C minus A. So there you are subtracting from each and every term the same thing. That's why again the terms are going to form an AP only. Okay. Over here it is giving to me that if these three things are in AP, then prove that these are also in AP. So understand, B plus C minus A upon A, comma C plus A minus B upon A, comma A plus B minus C upon A. Okay, this is some typing error over here. Okay, this is some typing error over here. Over here it should be B, and over here it should be C. Okay. Yes. So if these three terms are given to you in an AP, then the question is asking you about 1 by A, 1 by B and 1 by C. I said alright. Okay, understand, there is a pattern. If A is coming over here, minus A is written. If minus B is written over here, B is written over here. If minus C is written over here, C is written over here. Now this is the pattern. If we add 2 to all these three numbers, are these terms going to remain in AP only? If we add 2 to all these three numbers, then this is still going to remain an AP or not? Yes sir, this is still going to remain an AP only. Okay, the moment you do that, you will get to know something good is happening, because this expression is going to be A plus B plus C by A. This is going to become A plus B plus C by B, and this is going to become A plus B plus C by C. Yes or no? Okay, now these are also in an AP only, and now if I divide each and every term by A plus B plus C, if I divide each and every term by A plus B plus C, then also is it going to remain in AP only? Yes or no? So accordingly, divide all terms by A plus B plus C, it is still going to remain in AP only. Therefore 1 by A, 1 by B, 1 by C, they are also in an AP only, hence proved. Anyone is having any confusion in this? There should be none. Alright. Now there is one very important thing which we need to follow in order to select a few terms for an AP. If a question is saying that there are three terms in AP, then take those three terms like this: A minus D, A and A plus D. Obviously the common difference of these three terms is nothing but D only. This will help our problem solving. This will help, to reduce number of calculations in the problem solving. If it is given to me in the problem that 4 terms are in an AP, then take those terms like this: A minus 3D, A minus D, A plus D and A plus 3D. Over here the difference is 2D. Look, this minus this, if you do, what is the common difference? The common difference is 2D, not D. It is a very, very, very important thing. Alright, if the question is telling you to take 5 terms in an AP, take the 5 terms like this, because the common difference of all these terms is D, and this is going to reduce a lot of calculations. Alright, let's take an example based on this. If sum of first three terms which are in an AP is given to me 27, so I am taking the three terms as A minus D, A and A plus D. The summation of the three terms is given to me 27, means if you add, don't you think that D and D cancelled out? That is what I am telling you, and that's why I am telling you that take three terms in an AP like this, because this will reduce a lot of calculations. So 3A is equal to 27 means A is equal to 9. I said okay. So the terms and product of the first and last. Now understand, if the A's value is coming out to be 9, then the three terms will be 9 minus D, 9 and 9 plus D. The product of the first and the last, that is 9 minus D times 9 plus D. The product of the first and the last is given to me equal to 77. So we can apply A plus D into A minus D over here. So 81 minus D square is equal to 77. So from here D is equal to plus minus 2. So we have got the value of D as plus minus 2. So if we are taking D as 2, then the terms will be 7, 9 and 11. If we are taking D's value as minus 2, then the terms will be 11, 9 and 7. So these are the two APs which is going to form. This is an increasing AP. This one is an increasing AP because the terms are getting increased. Or we can say that the common difference is positive. This is a decreasing AP. We can say that the terms are getting reduced, and over here the common difference is nothing but a negative number. So keep these points in your mind. Alright, find 4 numbers in an AP. Whenever 4 numbers in an AP are needed to be taken, take these 4 points like this: A minus 3D, A minus D, A plus D and A plus 4D. What is the common difference over here? The common difference over here is 2D. Okay, such that the sum of the first and the last, sum of the first and the last is how much? Is given to you equal to 8. So the sum of these three things equal to 8 given to you means 2A equals to 8, gives you the value of A equal to 4. I said fine, and the product of the second and the third is 12. Okay, so in that case it is going to be 4 minus D and 4 plus D. The product of these two numbers, that is second and third, is given to you equal to 12. So this is 16 minus D square equal to 12, means D is equal to plus minus 2. So I hope you got the value of D now, and you can comfortably write down all the numbers. If you are taking D as 2, then the numbers are going to be 4 minus 6 comma 4 minus 2 comma 4 plus 2 comma 4 plus 6. Okay, and if you are taking d as minus 2, then it is going to be 4 plus 6 comma 4 plus 2 comma 4 plus 4 minus 2 comma 4 minus 2 comma 4 minus 6. So over here the terms are minus 2, 2, 6 and 10, and over here 10, 6, minus 10, 6, 2 and minus 2. Okay, so these are going to be the fourth term. Again, the upper one is a decreasing AP because the common difference is negative, and the lower one is an increasing AP because the terms are getting increased since the common difference has to be greater than 0. Okay. Now this is the 7th January 2020 problem. Let's try to solve this. 5 numbers are in an AP given to me. Okay, 5 numbers in an AP means I can take those numbers as a minus 2d, a minus d, a plus d and a plus 2d. Okay, the summation is equal to 25 given to me, so we can add all of these numbers and write equal to 25. So when you add this, all the d's are cancelled and 5a's value is coming out to be 25, means a's value is nothing but 5 only. Okay, calling it as 1. Okay, the next thing is, if one of the first if one of these 5 numbers is minus 1 by 2, all right. So now the numbers will look something like this: 5 minus d, 5 over here, 5 plus d and 5 plus 2d. Okay, and the product is 2520. Okay, I said 2520, calling it as equation 2. Okay, without calling it as equation 2, let's simplify this. There are multiple ways to solve this question. I would have told you another objective trick as well, but let's see. This is going to be 25 minus d square times of 25 minus 4d square equal to 504. Okay, so if that is the case, then we can assume t as something and accordingly we can solve our problem. But let me tell you that trick as well, because I think anybody can solve this equation, but not everybody will be able to apply directly like the way I'll tell you. So let's do that. Okay, if these are the 5 terms given to me in an AP, then either the AP will be increasing or decreasing. Yes or no? This is what we have seen so far. Okay. Now understand, if let's say the AP is increasing. Okay, let's say the AP is increasing. Then if this term is positive, these terms also needs to be positive only. Now there are 2 possibilities for these 2 numbers, that if this is negative, then this will also be negative, because if this is a negative number, then this has to be negative. But if this is negative, this may or may not be negative. But over here the product of the 5 numbers is given to me equal to 2520 only. That means what? One negative number cannot happen. One negative number cannot happen. Either all the 5 numbers will be negative, all the five will be positive, or 2 will be negative and 3 will be positive, because this cannot happen that 1 is negative and 4 are positive, because if that is the case, then the product can never be a positive number. So we can ultimately say that these 2 has to be negative number. Okay, so if these 2 are negative number, then either this will be minus 1 by 2 or this will be minus 1 by 2. If this is minus 1 by 2, then this will never be a negative number. Why? Because the mean of these 2 numbers has to be this, and 5 plus minus 1 by 2 upon 2 will be a positive number. So this cannot happen that this is a negative number. So 5 minus d has to be equal to minus 1 by 2. So from here we can say that d's value is going to be 11 by 2, and if d's value is 11 by 2, then I think we can comfortably get all these numbers quite comfortably. So d's value is 11 by 2 means this is minus 6. If d's value is 11 by 2 means this is minus 1 by 2. If d's value is 11 by 2 means this is how much? This is 21 by 2, and if d's value is 11 by 2 means this is 16. So what is the greatest number coming over here? 16. So without even calculating this equation, you guys can say that B for Bombay is going to be the correct answer. I hope you people understood this particular thing. Alright, moving on to the next thing. If the sum and the product of the first 3 terms in an AP are this. Okay, so 3a equal to 33 given to me means a is equal to 11 given to me, and their product, that means 11 minus d times 11 plus d is equal to 100 this. So we can say that 1 to 1 minus d square, 1 to 1 minus d square is equal to 105. So d square equal to 16 means d is equal to plus minus 4, right? Okay, and if this is the case, then the 11th term is what we want to find out. 11th term can be written as a plus 10d. So a is what? A is 11. So it is going to be 11 plus 10 into d. So if d is plus 4, then it is going to be 51, and if d is minus 4, then it is going to be minus 29. So 11th term is what we needed to find out. So let me see, 16 plus minus 4, yes, absolutely correct. So minus 40, if you do, 29 will be the, minus 29 will be the answer. Okay, wait a minute. 11 105, okay, that is correct. 121 minus 105, if you do, it is going to be 16. So d has to be equal to plus minus 4 only. 11th term is what we want to, okay, sorry. Now there kids can make mistake. Here kids can make mistake. They will see if the answer is given to you as minus 29, then they would have correctly marked it. Let me tell you, the first term that you have taken is a minus d, the second term is a, third term is a plus d. So here, if you talk about the 11th term, the 11th term is going to be a plus 9d only. Because the first term you have taken is a minus d, that's why the 11th term of the AP is going to be a plus 9d only. Feel it, everyone. So in that case, it is going to be 11 minus 9 into 4, that is minus 25. So minus 25 will be the correct answer. I hope you people understood this, because the first three terms of the AP you have taken like this. That's why the 11th term is not going to be a plus 10d, rather it is going to be a plus 9d only. So I hope the problem is clear to all of you guys. The answer is going to be D for Delhi. This was a problem asked in JEE Main 2019. Okay. Let A1, A2, A3 and so on be a few terms of the AP. If this is the thing given to me, then A6 upon A21 is going to be what? Okay. Alright, let's talk about this. This is nothing but sum of the first P terms of an AP. So it is going to be P by 2 times 2. Okay, P by 2 times A1 plus AP. One thing is that. Or we can also say that 2a plus p minus 1 into d, if d is the common difference we are assuming. And over here, this is the sum of first q terms, so q by 2 times of 2a plus q minus 1 into d. Okay, this is equal to p square upon q square given to me. So we can say that 1 by 2 and 1 by 2 cancelled over here, p and p cancelled over here, q and q cancelled over here, and the moment you take 2 common, so it is going to be what? It is going to be a plus p minus 1 by 2d upon a plus q minus 1 by 2d. We have taken 2 common as well from these two terms, okay, equal to p by q. Okay, then since we want to have a6 means a plus 5d and a21 means a plus 20d. So ultimately we want this thing to be equal to 5, means we want to have p's value equal to 11, and if you want this thing to be equal to 20, then we should have q's value equal to 41. Yes or no? So this has to be 5 by 41. So what is the answer? 5 by 41. No, sorry, 11 by 41, because p's value is 11, right? So the moment you put p is equal to 11 over here and q equal to 41 over here, this expression will become a plus 5d divided by a plus 20d, and that is nothing but a6 over a21. So the answer is going to be 11 by 41. So the answer is going to be D for Delhi. This question you might have solved in class 10th as well. In R.D. Sharma this is also there, and this was a problem asked in 2006 IIT JEE as well. Geometric progression, as I already told you, that if I am taking a number a and again I am multiplying by a same number, then this sequence is nothing but an arithmetic, this sequence is nothing but a geometric progression only. Just like an AP is all about A and common difference, a geometric progression is also about A and R. Okay, if I ask you about nth term of a geometric progression, then it is going to be A into R to the power n minus 1. Okay, if I tell you to write down sum of n terms of a GP, then it can be written as A times common ratio to the power number of terms upon common ratio minus 1, or sum of infinite terms of a GP is also there, A upon 1 minus R. Do remember these two formulas. An infinite GP summation can only be find out when the common ratio is less than or equal to, is the mod of R is less than 1 in that case only. Okay, yes. So how to identify whether a few terms are in a GP or not? Second term upon first term is equal to second term upon, is equal to third term upon second term, equal to fourth term upon third term, and so on. If that is there, and equal to r, we say r is the common ratio and the given sequence is an arithmetic progression. This is the formula for nth term of a GP. Alright, is this a GP or not? Let's check it out, because first term is 1. If you multiply this with minus 4, we're gonna get T2. If you multiply this with minus 4, we're gonna get T3. Yes. If you multiply this with minus 4, we're gonna get this. Yes, this is a GP. Now what is the common ratio R? The common ratio R is nothing but minus 4, and the first term is nothing but 1. So Tn, nth term of the GP, can be written as A into R to the power n minus 1. So that will be equal to 1 times minus 4 to the power n minus 1. So this is nothing but your nth term of the geometric progression. Okay, let's talk about this. If A1, A2, A3 are a few numbers given to me in a GP with common ratio R1, and B1, B2, B3 are few terms given to me in a GP with common ratio R2, then A1, B1, A2, B2, A and Bn are also in GP. Now you can understand that A2 upon A1 is equal to A3 upon A2 is equal to A4 upon A3, and so on. This is the case, and this is equal to what? R1. Also, if you see, then B2 upon B1 equal to B3 upon B2 equal to B4 upon B3, and so on. B4 upon B3 and so on, and this is equal to, by the way, R2. So if we are looking for this particular term, then this is going to be what? This is going to be you can see that this is going to be in a GP only. Yes, with a common ratio what? With a common ratio R1 R2. Yes, with a common ratio R1 R2, right? You must know this. This is the result rather, remember it. Okay. Yep. Alright, sum of first n terms of a GP. I just told you that this is the formula, A times of 1 minus R to the power R to the power number of terms upon 1 minus R. Sum of infinite terms formula is also there. So sum of infinite terms formula is what? It is equal to A upon 1 minus R. So keep that formula also clear in your mind. Okay. So this is a very good example. 3 positive numbers form an increasing GP. Increasing GP means common ratio is greater than 1. Okay. Increasing GP means common ratio greater than 1. Feel it? Yes, since the terms are already positive given to you, then A, AR and AR square. Let's say these are the 3 terms. Now if the terms are getting increasing, so AR has to be greater than A. Then A cancelled, the sign of inequality will not change because A is a positive number, so R has to be greater than 1. Okay, number 1. If the middle term of the GP is doubled, so if the terms we have made like this, then the question is saying that the new numbers are forming in AP. Okay. So that means what? If 3 numbers A, B, C are in AP, means middle ones double, that is 2B equal to sum of the rest 2, that is A plus C. So we can say over here that 2 times of the middle one has to be equal to sum of the rest 2. So this is going to be one such thing with us, and A can be cancelled from here, and 4R equal to 1 plus R square will come from here, and ultimately this is nothing but R square minus 4R plus 1 equal to 0, which is a quadratic in R. And finding out the roots of this equation, 4 plus minus under root 16 minus 4 upon 2. So this is going to be 4 plus minus 2 root 3 divided by 2. So this is going to be 2 plus minus root 3. So guys will say that, sir, D is also there, C is also there. Our answers are both C and D. But let me tell you, no. C is not our answer, only D is our answer, because since it was given to me that this is an increasing GP, the common ratio has to be greater than 1. The value of root 3 is roughly 1.732. So 2 minus root 3 is going to be lesser than 1. Yes or no? So that's why that is rejected, and the only option that we have to tick is 2 plus root 3. So the correct answer is going to be 2 plus root 3. Find the sum of n terms of this GP. Look, is this a GP? Yes, we need to multiply same number again and again. So this is a GP. Okay, what is the common ratio of the GP? 2 is the common ratio of the GP. What is the first term of the AP? 2. Okay, how to write down sum of n terms of the GP? 2 times 1 minus common ratio to the power number of terms upon 1 minus common ratio. So we can write this particular thing like this as well. So this is our summation of n terms of a GP in this particular case. Anyone is having any difficulty? There should be none. Alright, moving ahead. If we multiply this by 4, we get this. If we multiply this by 4, we get this. If we multiply this by 4, we get this. So is this a GP? Yes, this is a GP. So writing down the sum of n terms of a GP. So first term is 1 and the common ratio is this. So 4 to the power n minus 1 upon 4 minus 1 equal to 5461. Can we solve this particular equation to get the value of n from here? So this is going to be 4 to the power n equal to 3, 6 3 the 18, 8 1, 4 3 the 12, 3 1 5 3 the 15, 16 plus 1. So 4 to the power n is equal to 16384. Now I hope you can find out which power of 4 is going to form this kind of a number. So ultimately we need to factorize 16384. Let's factorize it. 4 for the 16, 0, 1, 9 for the 36, 2, 4. So 6 for the 24. Okay, 4 1s are 4, 0, 2s are 4. Okay, so 4, then 2s are 8, 2, 2, 5 for the 20, 2, 4, 6. Okay, and this is how much? 4. So this is going to give you 64. This is 4, this is going to 16, 4, 4, 1. So this is 4 to the power how much? 1, 2, 3, 4, 5, 6, 7, 8. Wait a minute. 16, 4, okay. Yes, this is the case. So I think you can easily get the value of n from here by just comparing. Okay, that's it. So this is 4 to the power 3, 7. So n is equal to 7. That's it. Okay. Yeah. Okay. There is one variety of problem in which you may not, you will not be able to find out GP directly, but this can be made a GP. This can be made a GP, but this may not directly look GP, but rather the trend is same digit is getting repeated. Okay. In these kind of problems, this is not a directly GP, but indirect application of GP. Let me tell you how we solve. This is an algorithmic process. Okay. First, we take 5 common so that 1, 1, 1 is created. Everywhere 1, 1, 1 will be created, and so on. Then we do what? We multiply this thing by 10 and divide by this thing as well as 10. Now if we multiply and we take that 10 inside, it is going to be 10 plus, okay, no, wait a minute. So what we do is we multiply this and divide by this by 9. So 9 plus 99 plus 999 plus 9999 and so on. This is going to happen. Always we are going to do the same thing. Whatever is written over here, just take that value common. Like 5 was written everywhere, so we have taken 5 common. The question will become like this, and then I have to divide as well as multiply by 9. This division wala 9 we are going to keep outside. The multiplication wala 9 we are going to take inside. So this will become 9, this will become 99, this will become 999, this will become 999 and so on. The moment we have written it this particular thing like this, we can write down this 9 as 10 minus 1. We can write down this 99 as 100 minus 1. We can write this 999 as 1000 minus 1 and so on up to n terms. Okay. Now if you observe one thing over here, that is 10 plus 100 plus 1000 plus and so on. These are some terms which are forming a GP. And this minus 1, minus 1, minus 1 n times will be coming, so ultimately it will become minus n. So this will become 5 by n times of, these are how many terms in GP? N terms. So how to write down the summation of these n terms is first term times common ratio is again 10 to the power number of terms minus 1 upon common ratio minus 1, okay, and then minus n is already coming over here. So this is nothing but the answer of the given problem. Okay, I hope you people understood this particular problem. There has to be no confusion at all. Find out the sum of first 20 terms of this particular thing. This problem was asked in 2013. So look, again and again same thing, 7 is getting repeated. So 7 we need to take common. So 0.1 plus 0.11 plus 0.111 and so on. First 20 terms, okay. And then if you see over here, we need to multiply by 9 and divide by 9. Over here it will become 0.9, over here 0.99, over here 0.999 and so on it will become. Okay, this particular thing can be rewritten as 1 minus 0.1. This can be written as 1 minus 0.01. This can be written as 1 minus 0.001 and so on. So over here if you see, it is going to be 7 by 9 times. Since these are 20 terms, so 20, 1 plus 1 plus 1 plus 1, 20 times minus 0.1 plus 0.01 plus 0.001 and so on till 20 terms will come, and I don't think there has to be any difficulty in order to write down the summation of these 20 terms. So 7 by 9 times 20 minus, what is the first term? 0.1 times common ratio is 0.1 Common ratio is what? 0.01 divided by 0.1. So that is going to be 0.1 only. Yep, 0.1 to the power number of terms, that is 20 minus 1 upon 0.1 minus 1, right? Okay, and simplify this, you're gonna get your answer. So answer me in the comment section below the video. What is the correct answer? Comment below the video, right? A, B, C, D option, which of the following is the answer? Okay, quite an easy problem. Alright, sum of infinite terms of a GP, we have already seen it is equal to A upon 1 minus R, and this summation can only be found out in the case when the common ratio's modulus is less than 1. Over here, if you see, is this a GP? Yes, 3 by 4. If you multiply over here 3 by 4, over here if you multiply 3 by 4, this is forming a GP, okay. Find the sum of the infinite terms of the GP, then it is going to be first term upon 1 minus common ratio, so it is equal to 1 upon this, 4 is the answer. 1 upon, first term upon 1 minus common ratio, so first term here is 1 and the common ratio is R, so sum of infinite terms is going to be first term upon 1 minus common ratio, always keep this thing in mind, okay. Yep, this is a problem. This is not even an AP, not even a GP. This is not an AP, not a GP. I will talk about this. This is an AGP, by the way. If you people have already studied this topic, then you can say that the correct answer. This problem is nothing but an AGP. Okay. Let's say, since we haven't discussed AGP yet, though we will cover it in today's session only, but since it has come earlier, so let me tell you an objective way how to solve this. If n can be any value, right, because there is no restriction given to us, so we can take n is equal to 1 objectively. The moment we take n is equal to 1 objectively, we can see that this term is going to be 0, this term is going to be 0, this term is going to be 0, and so on. So summation has to be equal to 1 only. So which of the following option is giving you 1 is the answer when you are putting n is equal to 1? This, yes, this can be our answer. This, no, this is giving you 2, this is giving you 4. Okay, so the only possibility is A and D, and I think there are high chances that A will be the answer, so you can mark it. Okay, this is an objective trick as of now I have shared with you guys. I will discuss AGP in this lecture only, so no need to worry about that. Alright, if each term of a GP is multiplied or divided by a fixed non-zero constant, then the resulting sequence is also a GP with the same common ratio. Okay, do remember this. Okay. Moving ahead, if each term of a GP is raised to the power k, then the resulting sequence is also GP with the common ratio r to the power k. Okay, one more thing, let me tell you that if these are terms in a GP, AR square, AR cube, and so on, and if I am taking log in all the three terms, log A, here log AR, over here log AR square, and so on, here log AR cube, then these terms will be in what? These terms will be in a, if these are in GP given to me, then these terms are in an AP. How AP? Let me tell you. This is log A only. By using the property of logarithm, this can be written as log A plus log R. Okay, this will be what? Log A plus 2 log R. Yes or no? This will be what? Log A plus 3 log R. That's it. So the common ratio, common difference over here is going to be what? The common difference over here is going to be log R. Do remember this thing, okay? If A1, A2, A3, B1, B2, B3 are two GPs with the common ratio R and R dash given, then the sequence A1, B1, A2, B2, A3, B3 will be having common ratio as R into R dash, and again will be a GP only. Okay, yes, in a GP a very important property, like in an AP, first term plus last term equal to second term plus second last term equal to third term plus third last term, and so on. This was happening in an AP. In a GP, first term times last term times, over here multiplication happens, equal to second term into second last term equal to third term into third last term equal to fourth term into fourth last term equal to fifth term into fifth last term, and so on. This happens for every GP, irrespective of the first term and the common ratio. Okay, let me tell you a few more important things over here. What kind of a sequence is this? Is this an AP or a GP? This is both. This is both AP and GP. Both AP and GP. AP with common difference 0, with common difference equal to 0, and GP with common difference equal to, common ratio equal to 1. So can a sequence be both AP and GP at the same time? Yes, a constant sequence. Okay, yes, if we have to take three terms in a GP, then we should take them like this. A by R, A R. Here the common ratio of the three terms will be R. If we have to take four terms in a GP, we have to take them like A by R cube, A by R, A by AR and AR cube. The common ratio will be R square this time. And if we have to take five terms in a GP like this, so we have to take it like this. Alright. Three terms are in a GP, the product of the first and the last term. Okay, three terms are there in a GP, so we should take them like this. A by R, A, AR. The product of the first and the last is 256, means A by R times of AR equal to 256, means A square equal to 256, means A's value is nothing but equal to 16. I said okay. The sum of all the three terms is 84, that means 16 by R plus 16 plus 16R equal to 84. Then the value of R will be going to be what? Can we evaluate? Yes, because the only one unknown is there. Okay, so let me take 16 common. If you take 16 common, 1 by R plus 1 equal to 84. So this can be rewritten as 1 by R plus R equal to 84 by 16 minus 1. So 1 by R plus R can be rewritten as 66 by 16. So can we get the value of R quite comfortably now? This is going to be 13, this is going to be 8. So we can get the value of R equal to 8 from here, I think. No? No. 4. No. Wait. Wait a minute. 16 if you do, no. 68. 68 means 34 by 8. No? Okay, wait. 68 by 16. 68 by 16 it will be. So this will be equal to 34 by 8. Okay, 17 by 4. Yes, 17 by 4 means R is equal to 4 will come. Yes, R is equal to 4. If R is equal to 4, then can you write down the three numbers? Yes, 4, 16, 64, that's it. These are the three numbers and the question is done. Yes or no, everyone? Yep. Okay, moving ahead. Four numbers are in a GP given to you. So the four numbers can be taken as A by R cube, A by R, AR and AR cube. Okay. The product of the first and the last is this. So A square equal to 32. I said fine. The sum of the second and the third is 12. So A by R plus AR equal to 12. Find those numbers. I think you can do it quite comfortably. So A square equal to 32 means A will be equal to 4 root 2. If A is equal to 4 root 2 means 1 by R plus R will be equal to 12 by 4 root 2 means 3 by root 2. So you can get the solution of the equation, because this can be formed as a quadratic in R. So 1 plus R square equal to 3 root 2 R. So R square minus 3 root 2 R plus 1 equal to 0. Solve this equation for the value of R. The moment you get the value of R, you can get all the terms quite comfortably. Do this question as part of homework now. Okay, beta. Alright. If the second, fifth and the ninth term of a non-constant AP are in GP given to you, then the common ratio of this GP is going to be what? Okay, second term of the GP can be written as A plus D of non-constant AP. Alright, fifth term will be written as A plus 4D and the ninth term will be written as A plus 8D are in GP as well. I said okay, and the common ratio is what question asking me. Let's say this is capital A, this is capital AR, this is capital AR square. Now let me tell you, if we do AR square minus AR divided by AR minus A, then this term is nothing but equal to common ratio only. Yes or no? So AR square's value is nothing but equal to A plus 8D. AR's value is nothing but A plus 4D. So AR's value is A plus 4D and A's value is nothing but A plus D only. So putting the values over here, we get 4D divided by 3D. So it is equal to 4 by 3. So the common ratio is going to be nothing but 4 by 3. That is D for Delhi is the correct answer. Yep. I hope you guys are clear with this. This problem was asked in JEE 2016. Harmonic progression, let me tell you the concept. If A, B, C are in AP given to you, then the reciprocal 1 by A, 1 by B, 1 by C are in HP. That's it. And if opposite is given, let's say A, B, C are in HP given to you, then their reciprocals, that is 1 by A, 1 by B, 1 by C, are going to be in an HP, in an AP. That's it. So that is the concept of AP. Is the nth term of the AP can be written as 1 by nth term of the AP. So that is 1 by A plus n minus 1 into D. There is no formula for summation of n terms of harmonic progression. Is this an HP? If we see the reciprocals of this, the reciprocals of this are going to be like this, which are forming an AP. That's why these following terms are going to form an HP. Okay, talking about the reciprocals over here, 11 by 10, 12 by 10, 13 by 10, 14 by 10 and so on. So this is forming an AP, that's why their reciprocal are going to form an HP. Alright, if the 20th term of the HP is 1, okay, then the 20th term of the AP is also going to be the reciprocal of that, that is equal to 1 only, okay. And the 30th term is minus 17, means 30th term of the AP is going to be minus 17, okay. Then A plus 19D is equal to 1 and A plus 29D is equal to minus 17. So we can say that 10D is equal to minus 18, means D is equal to minus 9 by 5. If D's value you have got, the question is asking you to write down the largest term. The largest term, let's say nth term of the AP, if you want to write down the nth term of the AP will be written as A plus n minus 1 into D. If we have got the value of D, then we can get the value of A as well from here, that you can get, and can write down the nth term as well. And the largest term, it is saying, of the HP, right, it is talking about the largest term of the HP, means smallest term of the AP. Smallest term of the AP will be what? I think you guys can find it out, that there will be no difficulty at all. Okay, if these are few of the terms given to me in an HP, then we need to prove that this kind of a thing is going to hold true. I said, okay, if these are the few terms in an HP, then 1 by x1, 1 by x2, 1 by x3 and so on are going to form an AP. 1 by x1, 1 by x2, 1 by x3 and so on is going to form an AP. If that is the case, then 1 by x2 minus 1 by x1 equals 1 by x3 minus 1 by x2 equals to 1 by x4 minus 1 by x3. These are all going to be equal. And if this is the case, then x1 minus x2 upon x1 x2 will be equal to x2 minus x3 upon x2 x3 equal to x3 minus x4 upon x3 x4 and so on. So if this is the case, then anything can be done based on this. x1 x2 can be replaced by let's say this is equal to D. Okay, if this is equal to D, then x1 x2 can be replaced by x1 minus x2 upon D, plus this can be replaced by x2 minus x3 upon D. Then next thing can be replaced by this and so on, and this can be replaced by xn minus 1 minus xn by D. So all of the terms can be combined. If you combine all of these terms, then first term and last term will remain. I think rest every other term will be cancelled out. So x1 minus xn by D will remain, and I hope you can write down the value of D as something and the problem will be done. Yes, right. The value of D you can write down quite comfortably without an issue, and if you have got the value of D, I don't think there will be any difficulty at all in order to write down these terms. Okay, if these are there, then 1 by xn equal to 1 by x1 plus n minus 1 into D. So from here you can get the value of D, just put it over here and the problem is solved, right? Okay, if a1, a2, a3 be in harmonic progression with a1 equal to 5 and a2 equal to this, okay, so 1 by a1, that is first term of the AP, will be 1 by 5, 1 by a20, that is 20th term of the AP, will be 1 by 25. Then we can say that this can be written as 1 by a1 plus 19 into D, that is equal to 1 by 25 minus 1 by 5 equal to 19 into D, means this is equal to minus 4 upon 25 into 19 equals to D. We have got the value of D. Now the least positive integer for n for which an is negative or 1 by an is negative, that is fine by us. So 1 by a1 plus n minus 1 into D should be negative. So this is how much? This is 1 by 5 minus 4 by 25 into 19 into n minus 1. This value should be negative. Now just solve this to get the value of n and the question will be solved. Okay. Alright. This is the thing given to me. These are the few terms A, B, C are in GP given to me. If A, B, C are in AP. Alright. If A, B, C are in AP. This is nothing but a GP of infinite terms. So x can be written as first term upon 1 minus common ratio. So 1 upon 1 minus A. Y is nothing but 1 upon 1 minus B, Z is nothing but 1 upon 1 minus C, alright. So if A, B, C are in AP given to me, I said okay, if A, B, C are in AP given to me, oh okay, if A, B, C are in AP, so minus A, minus B, minus C will also be in AP only. If we add 1 to all of these, then 1 minus A, 1 minus B, 1 minus C will also be in an AP. If we take the reciprocal of this, the reciprocal are going to form NHP. That's it. So the answer is going to be this, D for Delhi, right? This was a problem asked in 2005. Okay, arithmetic mean, two kinds of cases we gonna see, numbers and arithmetic mean inserted between numbers, inserted between. Okay, first talk about arithmetic mean of numbers. Arithmetic mean of numbers is nothing but, let's say these are the few numbers and I want to find out the arithmetic mean of these numbers, then it can be given by A1 plus A2 plus A3 plus A4 plus and so on, that is adding all the numbers divided by total number of numbers. This is nothing but the formula for arithmetic mean of n numbers. Okay, if there are three numbers given to me A, B and C, then the arithmetic mean is represented by A plus B plus C by 3. If there are two numbers, then arithmetic mean of A and B will be written as what? A plus B by 2. Okay, if A, B, C are in AP, that means B is the arithmetic mean of A and C only. Okay. Yes, n arithmetic means inserted between. Okay, let's talk about this as well. If let's say this is A and this is B, if I have to insert n arithmetic means, let's say this is A1, first arithmetic mean, this is A2, second arithmetic mean, this is A3, third arithmetic mean, and so on, this is nth arithmetic mean. So in total these are how many terms now? N plus 2 terms. These n plus 2 terms will be forming an AP now, that's it. This is the only concept. So if this is the first term, this will be the second term, A plus D, this will be the third term of the AP, A plus 2D, this will be the fourth term of the AP, A plus 3D and so on, this will be the n plus 1th term, that is equal to A plus ND, and this will be A plus n minus n plus 1 into D. This is basically n plus 2th term of the AP. That's it. Alright, if 6 arithmetic means are inserted between 1 and 9 by 2, find the fourth arithmetic mean. Okay, this is 1 and this is 9 by 2. We are inserting 6 arithmetic means in between. So A1, A2, A3, A4, A5 and A6. These are the 6 arithmetic means. As I just told you, this will be the value of A, this will be the value of A plus D, second term of the AP. This will be third term of the AP, A plus 2D, this will be fourth term of the AP, A plus 3D, this will be fourth term of the AP. This will be fifth term of the AP, this will be sixth term of the AP, and this will be seventh term of the AP, sorry, and this will be eighth term of the AP. So we can see that A's value is equal to 1 and A plus 7D's value is equal to 9 by 2 given to me. So we can see that 7D is equal to 7 by 2 means D is equal to half. The moment we have got the value of D as half and A's value as 1, the question is asking us to find out fourth arithmetic mean. Fourth arithmetic mean means A4, that is A plus 4D. We can find it out as 1 plus 4 into half, that is equal to 3. So 3 is the answer of this given problem. Again, I am telling you, if 6 arithmetic means are inserted between two numbers, so this is one number, this is another, and 6 arithmetic means are these, then these 8 terms are going to form an AP. This first arithmetic mean is going to be second term of the AP, this second arithmetic mean is going to be third term of the AP, this third arithmetic mean is going to be fourth term of the AP, this fourth arithmetic mean is going to be fifth term of the AP, this fifth arithmetic mean is going to be sixth term of the AP, this sixth arithmetic mean is going to be seventh term of the AP, and this 9 by 2 is going to be eighth term of the GP. Same thing is going to happen with geometric mean as well. Two varieties, geometric mean of numbers and geometric mean is inserted between the two numbers. If let's say A1, A2, A3 and till AN are few numbers given to me and I want to find out their geometric mean, then it can be written as multiplication of all these raised to the power 1 by n. If there are let's say two numbers, then their geometric mean will be what? A1 into A2 times raised to the power 1 by 2. If there are three numbers A1, A2, A3, then their geometric mean will be written as multiplication of all the numbers raised to the power 1 by 3 and so on. If A, B, C are three numbers given to you in a GP, then the geometric mean of A and C is nothing but B. So B can be written as A into C raised to the power 1 by 2. Okay, yes, and arithmetic means inserted between A and B. Let's say this is A, our first number, and let's say this is B, our second, the last number. Then G1, G2, G3, G4 and so on till Gn. These are n geometric means inserted between the numbers. Then this is first term of the GP, this is second term of the GP, this is third term of the GP, this is fourth term of the GP and so on. This is going to be n plus 1th term of the GP, this is going to be n plus 2th term of the GP people. This is the only concept over here also. Let's go into that. Harmonic mean. The harmonic mean of two numbers can be written as 2 divided by 1 by A plus 1 by B, and the harmonic mean of n numbers will be written as n is the number of the numbers divided by 1 by A plus 1 by B plus 1 by C and so on. If there are three numbers whose harmonic mean we need to write down, then we will write it like this. I hope it is clear to all of you guys. Okay, here also the same thing, A and B, H1, H2, H3 are the few harmonic means, H1, H2, H3 till Hn. Then these n plus 2 terms are going to form an HP, that means their reciprocals are going to form an AP, and we have to accordingly solve it as an AP. Okay, moving on to the next thing, we have to find out the arithmetic mean of 5 and 45. So this will be 5 plus 45 by 2, that is equal to 25. The geometric mean is 5 times of 45 raised to the power 1 by 2. The harmonic mean can be found out by 2 divided by 1 by 5 plus 1 by 45. Just solve this and your question is done. Alright. Theorem based on AM, GM and HM, there are two very important results. One thing is arithmetic mean is always greater than equal to geometric mean is always greater than equal to harmonic mean, and the second thing is G square is equal to AH, means geometric mean is always equal to arithmetic mean times harmonic mean. Okay, let me tell you the conditions where we need to apply this particular thing. AM is greater than equal to GM is greater than equal to HM. The conditions are very important. Number one, all terms are positive. All terms are positive. Number 2, minimum value is asked. And number 3 is product of the terms involved is good. Product of the terms involved is good. Whenever all these three conditions are getting satisfied, you guys can apply AM greater than equal to GM, because a lot of times the kids are not aware that when to apply AM greater than equal to GM in the problem. So those three conditions are going to be very helpful for you people. If the arithmetic mean and harmonic mean between the numbers this and this are between two numbers, okay, so the formula G square equal to AH, just apply it and find out the third thing. AM and HM is given to you. Geometric mean ka square is nothing but 27 into 12 ka whole square. So you can see that G is equal to 9 times 2, 18. 18 should be the answer, I guess. Okay, yes, show that this is the thing. So x and 1 by x, since x is greater than equal to 0 given to me, so x and 1 by x, the two terms are positive. Yes, number positive terms, and the minimum value of this expression is asked. Yes, okay, and the product of the terms, if you see x times 1 by x, it is coming independent of x, that's why it is good. So we can write down that the arithmetic mean of these two numbers has to be equal to, greater than or equal to geometric mean. So x plus 1 by x has to be greater than or equal to their geometric mean. The geometric mean of the two numbers can be written like this. So we can say that the x plus 1 by x will be greater than or equal to 2. Okay, and this equality holds whenever the terms are all equal. This equality holds whenever the terms are all equal, that is whenever 1 by x equal to x, that is whenever x equal to 1, then only this inequality is going to hold, otherwise this inequality is not going to hold. We haven't taken x equal to minus 1 because we have already taken x to be greater than 0, that's why. Okay. Show that this particular thing greater than n are different positive integers. Okay. A1 by A2 plus A2 by A3 plus A3 by A4 and so on is going to be greater than when A1, A2, n are different positive integers. So you guys can definitely do that without having any difficulty. So do try this as homework. Okay, do try this particular thing as homework. Alright, if x, y, z are positive real numbers such that x plus y plus z is equal to a, then prove that 1 by x plus 1 by y plus 1 by z is greater than or equal to 9 by a. So you can see that arithmetic mean is always greater than or equal to harmonic mean as well. So if you write down the geometric mean of these three numbers, sorry, arithmetic mean, it will be coming out to be like this. And if you write down the harmonic mean of the three numbers, it will be coming out to be like this. So from here you can have an idea that your question is done. Okay. If A, B and C are three positive numbers such that A by B plus B by C plus C by A. Okay, A, B and C are positive means A by B is positive, B by C will be positive, C by A will be positive. So applying AM greater than equal to GM. Terms involved are all positive. Minimum value of this expression is asked, and product will be coming out to be good because when you multiply this, B cancel, C cancel, A cancel. So you can write down that A by B plus B by C plus C by A by 3 will be greater than or equal to A by B into B by C into C by A to the power 1 by 3. So we can say that A by B plus B by C plus C by A is greater than or equal to 3, right? So the question is done. A is the correct answer. A, B, C are distinct positive numbers and A square plus B square plus C square equal to 1, then AB plus BC plus CA is going to be equal to what? Okay, I hope you guys know that A plus B plus C ka whole square will be greater than or equal to 0. So from here you can say that A square plus B square plus C square is greater than minus 2A minus 2B minus 2C. So AB plus BC plus CA is going to be lesser than or equal to what? I hope you can have an idea about that. Yep, one thing is that, and also you guys can do by different methods as well. So do try this as homework as well, because this question can be done in multiple ways once again. Okay, if you have studied vectors, then let me tell you that you guys can do this question by vectors as well. Let me tell you that method. If a vector, let's say P vector, I am assuming as A I cap plus B j cap plus C k cap, and I am assuming that the magnitude of P is equal to 1, then we can say that this equation is getting satisfied. Another vector can be taken as B I cap plus C j cap plus A k cap, then the magnitude of this vector will also be equal to 1 only. So cos theta, that is the angle between the two vectors, can be written as P dot Q divided by their magnitude. So in that case cos theta equal to what? In that case cos theta equal to AB plus BC plus CA will come, and I hope you guys know that cos theta always goes from minus 1 to 1. So this answer is going to be always lesser than 1 only, right? Yes, that's it. Okay. Moving on to the next thing. If alpha is going from pi by 2 to pi, then the minimum value of this expression is going to be what? Okay, minimum value is asked, terms involved are all positive, and the product is coming good because the product is independent of the value of x. Yes or no? So writing down the summation of these two, the arithmetic means of these two terms. The arithmetic means of the two terms will be written like this, greater than or equal to their geometric mean. The geometric mean of the two numbers will be written like this. Now a very important part, that is, if you cross multiply 2, then the expression becomes something like this. Mod sec alpha, because out of under root if you bring anything, mod will come. Now alpha is given to me over here in the second quadrant. In the second quadrant, from after school to college rule, sec alpha is negative. So when we remove that modulus, we should write minus over here. So this will be minus 2 sec alpha. Now a lot of guys will tell me the answer as A option, but the option A is not correct, rather the option is D for Delhi. A very good quality question, because this will give you a lot of conceptual clarity as far as concepts are concerned. Alright, then this particular thing, okay, whenever multiple things are written in the form of multiplication and minimum value is to be asked, then you have to first form different relations and then multiply them all together. Okay, yes, like taking these two terms and writing down the arithmetic mean, I will get something like this. Okay, then we can simply write it as 1 plus a1 is greater than or equal to 2 into a1 to the power 1 by 2. Then simply doing the things further, we can write 1 plus a2 will be greater than or equal to 2 times a2 to the power 1 by 2. Then 1 plus a3 is greater than or equal to 2 times a3 to the power 1 by 2, and so on. If you do, you will be able to get to your answer, because this symbol means multiplication. In case you don't know, then the meaning of this expression is a1 into a3 into a3 a4 till an is nothing but equal to 1. Okay, so when you multiply all this, you will get the left hand side over here 2 n times will become 2 to the power n. and this a1 into a2 into a3 into a4 till to the power 1 by 2. Now a1 into a2 into a3 and so on, the product is given to me equal to 1. So simply put it and the question is done. Okay. Yep. So this was a problem asked in JEE 2015. If m is the arithmetic mean of the distinct real numbers L and n, so L plus n can be written as 2m. This is equation number 1. Okay, G1, G2, G3 are 3 geometric means inserted between L and n. So this is L, this is n, this is G1, this is G2, this is G3. So we can say that these are the 5 terms in a GP. So this is the first term A, this is the second term AR, this is the third term AR square, this is the fourth term AR cube, and this is the fifth term AR to the power 4. So n is equal to L into R to the power 4. So R can be written as n by L to the whole power 1 by 4. Yes or no? And if you want to write down the terms now, this is nothing but our L, this is nothing but L into n by L to the power 1 by 4. This is nothing but n by L, L into n by L to the power 2 by 4. This is nothing but L into n by L to the power 3 by 4. This is nothing but L into n by L to the power 4 by 4. Yes, okay. Then the value of this expression G1 to the power 4 is going to be L to the power 4 into n by L. This is going to be L to the power 4. Okay, L to the power 4 I am taking common. So this will become n square by L square plus this will become G3. So n cube by L cube it will become, right? Okay, so this is what we are having, and now L plus n can be put as 2m. So just do that and the question will be solved. Okay, I hope you guys can do this and can find out the answer without any difficulty. I hope you will do the remaining problem. AGP, if you see now, look, if there are two things I pick up, one is an AP A1, A2, A3 and another one is B1, B2, B3, a GP. If I multiply the corresponding term of the AP with the corresponding term of the GP, that means A1 with B1, A2 with B2, A3 with B3 and so on, AN with BN, what we get is nothing but AGP, Arithmetic-Geometric Progression. Okay, yes, let's say AP is A plus D, A plus 2D, A plus 3D and so on. GP is B, BR, BR square, BR cube and so on. So if you multiply first term of the AP with first term of the GP, we're going to get this. If you multiply second term of the GP with second term of the AP, we're going to get this. Third term of the AP with third term of the GP, we're going to get this. Fourth term of the AP with fourth term of the GP, we're going to get this. So this is nothing but an AGP. Summation of AGP is very relevant, and for that what we need is common ratio of the GP. Okay, yes, let's say this is an AGP and its summation is what we want to find out. What we do is we multiply this AGP with the common ratio of the GP. Now common ratio of the GP was R, so we multiply this with R, we get R into Sn. If you multiply this with R, we are going to get ABR, but that ABR we are not writing below this, rather we will write down below the next term. Now this, if we multiply by R, we are going to get A plus D into BR square. We will write that thing below this one. This thing, if we multiply with R, we are going to get A plus 2D into BR square, but we are going to write it over here. Similarly, if you multiply this with R, we are going to write it below the next term. So then subtracting the two equations, we do get the summation of n terms of an AGP. I'll tell you some problems based on this as well. Let's take this problem up and understand how to find out the summation of AGP. Now look. 1, 2, 3, 4 and so on till 100. This is an AP, isn't it? Whereas if you see 2 to the power 1, 2 to the power 2, 2 to the power 3 and so on, this is nothing but a GP. So ultimately you guys can feel that first term of the AP has been multiplied with first term of the GP, second term of the AP multiplied with second term of the GP, third term of the AP multiplied with third term of the GP, fourth term of the AP multiplied with fourth term of the GP and so on, and that is nothing but an AGP. So if we want to find out its summation, let's first call this particular thing as S100, because these are first 100 terms that we are having. I said okay, moving ahead. Okay, then the common ratio of the GP is nothing but 2, so let's multiply this equation by 2. If you multiply this by 2, we're going to get this. Okay, if you multiply this by 2, we are not going to write below this, rather we're going to multiply this by 2 and write it over here. So we're going to get 1 into 2 square. If you multiply this with 2, we're going to get 2 into 2 cube. So we are writing it over here. If you multiply this by 2, we're going to get 3 into 2 to the power 4 and so on. Okay, somewhere here also some term will come, 99 into 2 to the power 100, and over here also 100 into 2 to the power 101 will come. Now subtracting the two equations on the left hand side, you will get what? You will get minus s100 equal to, over here if you see, it is 1 into 2 plus, over here it is 1 into 2 square plus, over here 1 into 2 cube and so on, 1 into 2 to the power 4 and so on, 1 into 2 to the power 100 plus, sorry, minus, because over here nothing is written at the top, that's why over here minus 100 into 2 to the power 101 will come. Okay, if you observe over here, these are the terms forming a GP. This will always happen. The moment you subtract, the terms will be forming a GP and the problem will be solved. Minus S100, I hope you know how to find out these are how many terms? These are 100 terms in a GP. So how to write down the formula? First term times common ratio. Common ratio is 2 to the power 100 minus 1 upon 2 minus 1. Okay, minus 100 into 2 to the power 101, just simplify it and write down the value of S100. You will be able to have your answer with you. I hope the problem is clear to all of you guys, everyone. Okay, I hope the problem is clear to all of you guys. Always this very basic method we have to follow and the problem will be solved. Okay, over here find the sum of first n terms. Okay, over here if you see 1, 4, 7, 10, 13 and so on, this is the AP. And if you see 1 by 5, 1 by 5 square, 1 by 5 cube, 1 by 5 to the power 4 and so on, this is the GP. Okay, this is an AGP, that's why. Okay, and we need to find out the sum of infinite terms of the given series. Now you can find out. I am giving you this problem as part of homework. There has to be no difficulty at all. I believe you guys can do it quite comfortably. Summation of the terms, the last important part in this particular lecture. Now look, this is a work of laziness, but a lot of guys are very much confused about this topic. If I want to write down T1 plus T2 plus T3 and so on till TR, the very same thing I can write it like this as well, not TR, TN rather. Okay, now let me tell you this particular thing, that if sigma TR r equal to 1 till n, we have to go, then whatever is written over here, in place of that r equal to 1 we need to put, then r equal to 2, then r equal to 3 and so on till r equal to n. And in between these things we have to put dot 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 dot. So I hope this is how we open the sigma and this is clear to all of you guys. There are few properties of sigma. Let me tell you that if there is anything in multiplication a constant, then that constant can be taken outside of the sigma whenever it is written in the form of multiplication. Okay, if in between the sigma plus and minus is there, then we can split about that plus and minus. Now over here the value of this expression is going to be n, not equal to 1. A lot of guys believe that this value has to be equal to 1, but no, when you put r is equal to 1 over here, it will give you 1, then you put r equal to 2, it will give you 1, then you put r equal to 3, it will give you 1, then you put r equal to 4, it will give you 1 and so on till n times. So 1 plus 1 plus 1 n times is going to give you nothing but n. Okay, yes, since this is a constant, this constant can be taken outside and hence can be written like this. Okay, let me tell you few more properties over here, that if sigma cannot be, sigma is not distributive about division. You cannot write it like this, that if two things are written in sigma, you have written it like this. No, this is going to be wrong. Okay, you cannot distribute sigma over division and multiplication also. Sigma is only distributive in the case when plus and minus is there in between the two modulus, things. Okay, sigma r is n into n plus 1 by 2, sigma r square is equal to n into n plus 1 into 2n plus 1 by 6, and sigma r square is the square of this only, nothing else. Do remember these formulas, as these are very basic and very important ones. Okay, alright, moving on to this particular thing, find the nth term and the sum of the n terms of this particular thing. Okay, now there are some variety of questions, summation series, in which you need to write down the general term. Like over here you need to write down the general term. Over here observe a trend, that the first term is, let's say r, so this is the first term, so this is r equal to 1, this is second term, so over here it is starting from 2, this is the third term, so over here it is starting from 3. Okay, number 1. Number 2, always the second value is 1 more than the earlier one. Look, over here also the second value is 1 more than the earlier one, over here also 1 more than the, so it has to be r plus 1. And here if you see this value, the difference between this and this is always 3. Yes or no? The difference between this and this is always 3. So this is nothing but your general term, rth term. So number 1 kind of problems are there in which you need to think general term on your own. So here if this is TR, rth term, then sigma TR going from R equal to 1 till n is going to give you the summation. So we can write it like this, R into R plus 1 into R plus 3 going from R equal to 1 till n. So this is going to be what? We cannot distribute about multiplication. So rather we are going to simplify it inside only first. So this is going to be what? R times of R square plus 4R plus 3, where it is going from R till n. So this is going to be sigma R cube plus 4 sigma R square plus 3 sigma R. Okay. So this is going from where to where? This is going from R equal to 1 till n. So we know the formula for this as well, n into n plus 1 by 2. We know the formula for this as well, n into n plus 1 into 2n plus 1 by 6. And over here also we know the formula that it is going to be n into n plus 1 by 2 ka whole square. Just put that and the question is solved. I hope the thing is clear to all of you guys. Alright, find the sum of the first n terms of this particular series is what the question asking me. So let me write down the series first. 2 into 2 square plus 3 into, okay, 3 square it is. Okay. I hope the question is visible to all of you guys. Alright, let me tell you how to solve this particular problem. Okay, if you segregate this into two parts, 2 square plus 2 square. If you segregate this into two parts, 4 square plus 4 square, and so on. If you segregate this into two parts, 6 square plus 6 square, the problem will be solved. Okay, yes. Here if you take this and so on. If you take these kind of terms, so it is going to be 1 square plus 2 square plus 3 square plus 4 square and so on till n square. And now what is remaining will be the terms which I am going to underline by green. So this will remain. So over here 2 square plus 4 square plus 6 square and so on will remain. Okay, now over here you can write down this as n into n plus 1 into 2n plus 1 by 6. So not an issue. But over here if you see, this can be written as 1 into 2 ka whole square, this can be written as 2 into 2 ka whole square, but this can be written as 2 into 3 ka whole square and so on. So over here this is n into n plus 1 into 2n plus 1 by 6 plus this is going to be 2 square times of 1 square plus 2 square plus 3 square and so on. But over here, since this is going from first n terms, so this will go till n square, I guess. No, n by 2 ka square only. So accordingly you will be able to get the value of this as well and the question will be done, right? Okay, moving on to the next thing. Method of difference is another important variety of problem. Method of difference means what we have done in AGP, quite similar method only. Let's talk about this. Now this is not an AP, not a GP, not an AGP, and still if you want to write down the summation, okay. So what do we do is sum of n terms is what we want to find out of this particular thing. 5 plus 7 plus 11 plus 17 plus 25 and so on till nth term. I said fine. Sn is what we want to find out. So what we do is we simply shift. This time we multiply this with 1 and simply if we multiply this by 1 we get 5, but we don't write it below this, rather we write 5 below this, then 7, then 11, then 17 and so on. So over here Tn minus will come and over here Tn will come. Okay, the moment you subtract these, over here you get 0, over here 5 plus 2 plus 4 plus 8 plus 10, 6 plus 8, 6 plus 8 and so on till minus Tn. So over here till over here, if you see from here to here, how many terms are these written? From here to here, how many terms are these? N minus 1 terms, n minus 1 terms. So the value of Tn is going to be nothing but 5 plus n minus 1 terms in AP, yes or no? So how to write down the summation of n minus 1 terms? N minus 1 terms by 2, 2a, that is 4 plus n minus 1 is the number of the terms, so n minus 2 will come into D. So 2 times of n minus 2. So this is your Tn. Once you have got Tn, Sn is nothing but sigma Tn. That's it. Just calculate the value, the question will be done. Alright? Yep. So this is method of difference. Okay, talking about this, the very same thing is there. 4, then 6, then 8 and so on. So you guys can do the similar problem of procedure over here as well. I am leaving this part as homework for you people. Method of difference, Vn method. Now this is again one such variety of problem. Let's talk about this. Okay. Over here what you do is always this kind of a thing, whenever do comes, what you do is just create the difference of this. So 4 minus 1 upon 1 into 2 into 3 into 4. Now look, this will always be same only. So that will be 1 by 3. That will be 3 only always. Look. So that's why we have divided by 3 and we have multiplied by 3. The multiply wala division 3 we have written as biggest value minus lowest value. That's it. Always. And then we will be able to, third term if you see, it will be 3 into 4 into 5 into 6. So that can be written as 6 minus 3 upon 3 into 4 into 5 into 6 and so on. Okay. So over here if you see, what we have done is basically we have multiplied and divided by 3 this expression. So this we have kept outside and this we have taken inside, and then over there this 3 has written as 4 minus 1, this 3 is written as 5 minus 2, this 3 is written as 6 minus 3 and so on. Nothing else. So 1 by 3 times of 1 by 1 into 2 into 3 minus 1 upon 1 into 2 into 3 into 4 plus 5 upon 2 into 3 into 4 into 5 minus 2 upon 2 into 3 into 4 into 5 plus 6 upon 3 into 4 into 5 into 6 minus 3 upon 3 into 4 into 5 into 6 and so on will happen. So over here few of the terms will be cancelled. Look, like this and this goes away. So over here you will see that this and this is cancelled, this and this is cancelled. So ultimately what will happen is 1 by 2 3 4, 1 by 2 3 4, then over here is 1 by 3 4 5, 1 by 3 4 5 and this. The terms are getting cancelled like this. So minus wala thing is getting cancelled only if plus wala thing is coming to cut it down. So ultimately what will remain is 1 by 3 times of minus wala thing will remain at the end and minus wala thing will remain at the end. So that is going to be what? N. N upon 1 by 1 into 2 into 3 minus n upon no, that is the remaining thing will be 1 by n plus 1, n plus 2, n plus 3. Okay, so this will remain. So this is going to be our answer, that's it. Right? Okay, moving ahead. Find the sum of this particular series. The same thing you have to follow. Just try this as homework. This is for JEE Advanced only because in mains these kind of problems does not come. So do practice this as well. These are the few problems I am giving you as part of homework. This was a problem asked in JEE mains. So do try to attempt these kind of problems. These are a few simple problems I am leaving for you guys. The more you're gonna practice, the more you're gonna retain. And as I told you, I have covered all the concepts from the chapter sequence and series, but ultimately what you have to do is you have to practice all of these questions. These are few of the good questions that have come in the recent past. That's why I am giving you as part of homework. You guys can avail the solution of these comfortably. There will be no issue in order to access the solutions of these questions. So do solve these relevant questions and do make best out of these questions, because this one PDF is surely going to clear a lot of doubts of yours. So that's it for today. Keep learning, keep shining, keep rocking, keep enjoying. We will do more sessions for you in the upcoming days as well. So keep learning, keep shining, keep rocking, keep enjoying, and let's make most out of this, because this time will not come back again. So make most out of this. Thank you so much. Bye bye. Take care. Happy learning. See you.